If you find the content relevant and really worth, please do share and subscribe for our channel. Let's start. In the given sum, it's the fact that seg OP is perpendicular to chord AB. We are supposed to prove AB is congruent to BP. So if you see in this circle, we have a circle with center O and seg AB is a chord. From the center, a perpendicular is drawn to the chord. If suppose a perpendicular is drawn to the chord, the perpendicular bisects chord AB. That is, we have to prove AP is congruent to BP. For this, we'll have to do a construction, and my construction is join OA and OB. Now, if I join OA and OB, OA and OB are the radii of the same circle. So, I'll come to know that OA is congruent to OB. Now, let us enter inside these two triangles. Let's see which are the two triangles. First, in triangle OPA and triangle OPB, we can tell measure angle OPA is equal to measure angle OPB equals 90. Reason for this is OP perpendicular to AB given. Now we have a right angle. In this, hypotenuse OA is congruent to hypotenuse OB because they are radii of same circle. Next, I have seg OP congruent to seg OP. This is common side. Okay, so if we check out properly, we have two triangles, both of them are right triangles, and in that hypotenuse OA is congruent to hypo OP, and we have a common side. Therefore, triangle OPA is congruent to triangle OPB by hypotenuse side test, or we can write right hypotenuse test, right angle hypotenuse test, RHS test, what we call it, RHS test, right hypotenuse side test. So if the two triangles are congruent, if I say that if two triangles are congruent, I'll get some spare parts for it. Therefore, seg AP is congruent to seg BP. Reason for this is corresponding sides of congruent triangles. Hence, we can tell, hence seg OP bisects chord AB at point P. So we can tell that my segment OP bisects chord AB at point P. That is, AP is congruent to BP. That is what we were supposed to prove.